Morning.
Boss.
All right. Can you confirm you can hear me by typing a Y in the chat box? Do I see Y? Fantastic, fantastic. Awesome, 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 awesome. All right. So good morning once again. Today, welcome. I want to welcome you guys to this month's knowledge sharing session, and is on building resilient systems through effective software quality assurance. I'll just put up a poll just so that we get a sense of the knowledge level of participants regarding this topic. Please let me know if you can see the poll. All right. We already start seeing results. Great. So let's just do this quickly so that we can start. Few more people. Okay, interesting results. In 1 minute, we'll be taking it down. 15 seconds more. Once we hit 70% participation, we are good to go. All right. Poll is ending. Sharing results. So we kind of have like, well, 16% knowledgeable and experts. We have 42% new to the domain, and that 42%, we just know bits and pieces. I think that's the bucket I fall in, right? I fall into, right? Okay. That's out of the way. Okay. All right. So in the build-up to today's session, we had said that software quality assurance and testing are not just merely steps in software development process, but are critical components in ensuring the resilience and robustness of the software applications we're building, right? Now, when it's appropriately done before deployment, it helps prevent costly errors, it enhances user satisfaction, and maintains the trust of stakeholders. Now, speaking about costly errors and maintaining the trust of stakeholders, we just over a week ago, we would recall the global IT outage occasioned by CrowdStrike's erroneous EDR update. For those of us who don't know, EDR are like your antivirus software, right? Now, for those of us in the tech assurance WhatsApp community, we discussed that CrowdStrike incident extensively. That incident was caused by weakness in software testing process. It impacted about 8.5 million computers globally, according to Microsoft, and is estimated to have cost Fortune 500 companies about $5.4 billion. Crazy stuff, right? Crazy stuff. Airlines were grounded, banking services halted, emergency services severely impacted, and possibly lives were lost, right? Depending on who is reporting, right? And all of this because of an undetected software error during testing that was rolled out to customers, particularly customers of CrowdStrike. CrowdStrike controls about over 20% of the EDR market, and this issue affected Windows operating system. So again, you begin to picture the scale of this program, of this problem. So our conversation on software quality assurance couldn't have come at a better time. one thing is clear, right, from that incident, and that's the fact that organizations are already rethinking their software testing and deployment strategy. I expect that yours is also doing the same thing. My name is Anthony Ayuno, and I'm your anchor for this session. Our speaker this morning is a friend of mine, right? Yeah, I've got very cool friends. Her name is Waoni. She is a seasoned IT consultant with several years of experience specializing in quality assurance and software testing and project management. She's got diverse background that cuts across finance, healthcare, telecoms, name it. She holds an MBA from the Lagos Business School, and she has a certification in software testing from the International Software Testing Qualification Board. She is also a PMP holder who is committed to empowering the next generation of software testers, right? And we are indeed honored to have her share her wealth of experience with us in this month's knowledge sharing session. I must warn us, right? This is like a 5-6 day course that is being crashed into 45 minutes to 1 hour. So I'll say, please, let's put away distractions and pay keen attention. All right. So, over to you.
Hi, good morning, everyone. This introduction,
Maybe like,
wow, as in, I was looking back, please, what are you referring to? Is there another O on this call? But yeah, thank you. Thank you for that. Thank you for having me. It's just, so interesting. Like you said, this session won't have come at a better time. You know how we plan stuff, and God also has a plan, because we've been talking about having this session for a very long while, and we finally decided to have this, and CrowdStrike decided to strike as well, right? But yeah, it's good that we're looking at software quality assurance, which is very key in this world where it's a global village. I was also looking at the poll, and I see that a few people do not have any idea about software. They're new here. We have mid-level people and we have experts. So as we go, please, I would like it to be as interactive as possible. We'll have questions at the end, but you can maybe send your messages, just drop your comments and we'll have a conversation. This is also a crash course. Like, it's a lot of information, but I think that is valuable information that, normally you would not think that, oh, there are methodologies to this and the impact on, and the value of software testing. So I'll go right into it. So we're talking about building resilient systems, and building resilient systems using software quality assurance as a key component, because every system that is being built, you want to make sure that it delivers the purpose, it achieves the purpose, and also how do you recover from issues, because who are the developers? We're humans. Humans make mistakes. So you need to make sure that, okay, at whatever point, how do we minimize? So sometimes I think about software testing as mitigating risk and offering quality, offering value while you try to mitigate whatever risk that you encounter. So we'll be looking into some of just highlighting the disasters that have occurred, some of them that have occurred, what the cost is, software, what are the causes of software failures, looking into quality assurance and the opportunities in this career path. So I trust that this will be an interesting session. Let's start with CrowdStrike, the ones that struck. So it's really been, I think, talking about the trend from 2 weeks ago till now and the impact of what the software updates that CrowdStrike deployed. So they have one of the applications, the Falcon, and they were supposed to send updates to it. And one of the major clients is Microsoft. I can count like how many people or organizations globally use Microsoft's applications, right? So we use Windows applications. It would be like a global thing. And this update that they had pushed, it was supposed to mitigate, against threats. So the application is supposed to be able to detect, new threats that have been coming up. But however, it introduced a bug in the system that made it crash. So every Windows application that was online at the point where that update was pushed. So you have your phone normally, and sometimes you say, oh, update, you click and you update. So you choose to update. But there's some updates that are pushed, especially, for applications, for systems. There's some updates that are pushed automatically because you've already accepted the settings. You already say, okay, I want to protect my system. It's like an antivirus. I already have an antivirus working, so I don't have to go every time to be updated. So it goes automatically. And this update was pushed, and every Microsoft system that was online had a blue screen of death. A blue screen of death is when you see a blue screen on your computer and you cannot do anything. So imagine airlines, imagine hospitals, imagine like trading centers. Name whatever application or anybody that uses a computer. I'm just trying to paint the picture and the impact of what this, so-called bug had cost. And 8.5 million computers globally could not work for a moment. We said that they lost almost 5.5 billion globally, like just as a result of this. And like, this is a major disaster. They haven't begun to even count. We don't know what if, like, I watch Grey's Anatomy, and I'm not a doctor, but yeah, I love the series. And in Grey's Anatomy, you see where they're using maybe automated systems for surgeries. And imagine having a surgery and you have blue screen. Where is the doctor? How are they going to navigate? So the risk is enormous. The risk is enormous. The risk of software disasters are enormous. So we'll be looking at how we can mitigate this risk. I'll just highlight some other, this was a bad trade that happened, like an application that was supposed to engineer good trades. He started buying, so for a stock company, he started buying any trade. So imagine investing in an application that buys any trade instead of even analyzing and choosing the right state trade to buy. So they literally spent $7 billion on unintended trades. The company ended up going under after 1 year because they couldn't recover from that loss. Nissan, they launched cars that the airbag had an issue, and it was as a result of a bug. They had to recall 1 million cars. The one that happened in Nigeria, I think a few years ago as well, Airtel, they were updating their billing system and their charging system, what enables you to recharge and everything. And during that update, there was also a bug that started giving people free airtime. The company also lost over 2 billion naira at that point. So the risk of software disasters is, like, we can go on and talk about it, but let's really go. And I just also wanted to highlight the cost of non-conformance. And when we talk about non-conformance, we're talking about the cost of not implementing quality. That's what it means. The cost of not, implementing quality in your delivery. What's the impact? We have analysis that says that companies actually, like, globally lose $1.1 trillion. It is so major, but yet I don't know how the major has become the minor, but that's why we're talking about it, and that's why we're highlighting it. It can cause reputational damage, loss of life, will name, the cost. But now, when you think about it, why do these things really happen? Why do we have all the software disasters? Like I mentioned, bugs. So you've created an application and there is a bug, there's a defect. It's not working the way it's supposed to be. Something is not working appropriately. And you still go to launch, you still go to deploy. Probably you tested and it was missed, but why was it missed? Did you go through the right process? So some of the causes are bugs. There can be error in design. So before an application is created, there's a design process. How do you create this application? So there can be errors in design, or even if it was designed properly, what's the, implementation? How has it been implemented? Did you even test the application itself? Do you understand? Do you have integration issues? Most of the applications that we have now, they're not standalone. They communicate with one another. When you talk about integration, you're saying one application or one component talking to another component. I'll give you a typical example. We all have, bank apps on our phone, right? From your phone, you can recharge. From your bank app, you can recharge. Like I want to use simplest examples. So you can recharge your phone. But how do you do that? Think about it. How does your bank connect to deducting money from your account and giving you airtime? It's because there's an integration. The telecoms has, an application interface that is talking with the bank. So that's an integration. What if that integration is not working? It will result in a failure. Scalability problems. You have more customers now. You want to expand, but you did not cater for expansion and you're just going. You would have failures. Security vulnerabilities. There's people that they do not even think about security in most of their deliveries, and their applications are susceptible to hacking. Those things are causes of software failures. Environmental factors. Sometimes you have where your servers are and maybe there's no power. Power suddenly went out and the thing is overheating. The application running on it begins to shut down. So there are different things that can actually cause software failures. So that would bring me into talking about the solution, part of the solution. And this solution that we're referring to is software quality assurance. And I'm highlighting software quality assurance and testing because most times people think that it's the same thing. The software quality testing is a part of software quality assurance, but they are not the same. Software quality assurance is the process to ensure that the software meets its requirements. So it's a process. It's the flow. How do I create this software, achieves this purpose, and it's able to serve the users? How do I create this software that is reliable and works correctly, that can withstand disruption? That's quality assurance. You're thinking about the process. You're thinking about the flow of how it will work. While testing now is implementing the activities to test the application. So I'll think of testing as a product. So I am testing what you have created. While quality assurance is how you creating what you create. I don't know if that makes sense. But testing is part of quality assurance. Quality assurance, when you think of quality assurance, think of, process, ensuring that the process works, ensuring that there's a method that you are adhering to before you deliver a solution. And testing is validating that application to ensure that you do not have issues, to ensure that it is working, to ensure that there are no issues. You're trying to identify issues. When you think about testers, think about detectives, people that are literally trying to break the system. I want to see if, it's working as it should. I'm checking all the possible scenarios of how this application should work. So that's how software testing and quality assurance, go. And this is just showing how they collaborate. So it's testing under quality assurance, the collaborative approach of both. Software quality assurance and testing, they collaborate with developers, project managers, everyone in the software development lifecycle. Testing gives the feedback to say, okay, I have checked this application. I detect that maybe you can buy airtime on this bank app. You can't pay bills, or I can't even see my account balance. And quality assurance saying, why are we having these issues? When did we define what it's supposed to be? Did we define that you should be able to buy airtime? If we defined it, how was this code created? Did it go through all the right processes to avoid this issue? And now that we have this issue, how are we fixing it so that it doesn't happen again? So testing gives the QA feedback, and they go hand in hand. So it is a process. Quality assurance, one key thing I want us to note is testing is part of quality assurance. Not, most times we kind of use it interchangeably, but to be clear, when you think about it, just think about quality assurance as ensuring the process works, testing, ensuring the product works. I feel like I'm talking to myself. Are you guys listening here?
Well, with you.
Okay.
Following.
It just seems really quiet, but yeah.
We don't want to distract you. Please go ahead.
Okay. Thank you. Good. Getting good feedback. Okay, so now I'll look at the methodologies, because remember, what are we trying to do? We're trying to look at testing. We're trying to look at software quality assurance in building resilient systems. So how do we achieve it? Because when you think about it, you think that is a no-brainer. Like you assume it's a no-brainer, like, oh, create an application, make sure you check it's working before you go. Just check, like just verify. Like sometimes, developers, most times they even think that, oh yeah, I created this thing, it should be working. Let me even just look at it. There's also the bias of they're the ones that created it, so I assume that it's working, or I know what I'm supposed to be checking. What if you have a blind spot? So there is a method to this. And when you think about the impact that we have, we have highlighted at the beginning of the session, think about the loss. You would realize that it is very, very critical to follow a methodology to mitigate any form of risk. You can't take it for granted. So looking at software quality assurance methodologies, there's the waterfall. So they are really just approaches, frameworks on how the software is built. I would go into software development lifecycle. We're going, a bit technical, but still in simple terms. Okay, some of the methodologies are waterfall, agile, and DevOps. So waterfall says design, build, test, deploy sequentially. So when I design this application, then I go and build. So design is creating the concept. How would it be? What's the look and feel? What are the integrations? What application is it talking to? Then you build. Build is actual, the coding. Then you test once you finish building, and you deploy. Deployment means launching into live environment. That's the waterfall. So it's sequential. It's just a straight line, one after the other. The output of one goes into the other. The output of design, that's what you use to build. The output of build, that's what you test. And once you have your test reports, you deploy. It's sequential. That's the waterfall methodology. And that's the process to which, the application will be tested. Then you talk about the agile, because now, like I've mentioned, the world is a global village. Things that innovation is coming up, very fast. Things are changing quickly, really, really quickly. And you don't want to wait maybe 6 months for an application, for you to launch an application or to launch a service that people even need, or that you need to even make money from, right? Because at the end of the day, everything here is a business. We need to give value. So whether you're giving value for free just because you want to create impact, or you're giving value for money, there is an end goal. And how do you want to achieve that goal? So Agile comes and says, let's minimize all these processes of saying, if I don't finish designing, I have to build. If I don't finish building, I will test. I want us to work in compartments. Let's design, build, test, deploy in small compartments. I'll use my bank example here again. So instead of waiting for the whole bank app to be ready, create a particular model in a short time. Sprints happen maybe 2 weeks, max 1 month, but mostly 2 weeks. So in 2 weeks, let's create the model of, seeing your account balance. So you design how you want it to look, they'll build, you test, they'll deploy. So you see an application that launches just a segment of what it's supposed to deliver. That's how Agile works. And when you talk about DevOps is integration between development and operations. So we already have existing systems in the world already. And you want to update, you want to improve, you want to change, because customer needs, customer demands are changing over time. How do you integrate your existing operations with your new application or with the updates? That's where DevOps comes in. So it's continuous integrations, continuous development. So you design, build, test, deploy. Everything happens at the same time with the operations team, so that there's a handshake and there's just a smooth delivery. So you see that sometimes you see an application and you see how it changes, they've done an update and you don't even feel it. It's a smooth transition. It's because there's an integration. Most times, most organizations now are using DevOps, because it's easier. It's, the customers do not even experience any issues. Transitions are smooth. So these are some of the methodologies in software quality assurance. We would go into looking at how do you now choose the right method, because all these methodologies are so that you can test your products properly, and at every phase you are releasing a product that is error-free. That's the purpose of following a process, because if not, you can come and just say, create this application, verify it or test it in any way you want. There's no method. But when you follow the right methodology, when you think about, look at CrowdStrike now, part of their learnings that they had mentioned was the fact that the way they deploy is going to change now. They're going to deploy in trickles. They're not going to just deploy globally. I'm sure that they would have an environment where they will have a set of people where they deploy anything, any updates, and even see how it works before they launch, they deploy globally, so that you don't have this kind of impact. So when you're thinking about methodologies, going back here, just when you're thinking about the methodologies as how software testing comes in, is what's the process of designing? How do you design this application? What's the process of building? If I'm going to code, how do I code it in a way that at the end of the day, I minimize risk and I mitigate issues? Testing, how do I test? At what point do I start testing? Deploying, at what point do I deploy? How do I deploy? At what is my success criteria before I deploy? And when I say I deploy, for people that are new here, I mean, how do I launch to customers? How do I make the application live? So even choosing the right methodology is very key. So some of the things that you think about when you're choosing the methodology for your software testing, you think about the project size. How massive is this thing? How complex is it? What requirements do I have? Do you understand? What are my team's capabilities? Do you understand? Do I have experienced people in my team that are able to work? So if I'm saying I'm doing Agile and I want to work in sprints, I have to have people that are able to collaborate, people that can work fast. Do you understand? Because I'm doing everything at the same time, but in a short time. So there's no time to wait for one person. There's, people always have to be in sync with what you're doing. So what are your capabilities? How fast does my customer need this? How fast do I need to get it out there? So those are some of the things that you need to consider when you're choosing a methodology of, of delivery or of testing. Or let's give an example of airplanes now. I want to create an application, as part of airplane. This is, airplanes are very, delicate. I don't want to rush. I'm thinking, let it take me 6 months, but let me get it right. And how do I do it, right? So I might say, okay, I want to use waterfall, but I already have an existing application, maybe I should use a hybrid approach. I don't want to waste too much time. I want to use waterfall, but I also want my operations team to be involved because it's existing. So you can, combine approaches. But the point here is there's a method. There are principles that you need to follow to ensure that your system is built fit for purpose and, is resilient to, is less susceptible to attacks or risks or even defects. Then now I'll just like to highlight the software development lifecycle, because we have talked about the methodology of software testing, like, oh, there's a method to this, but there's also a process. Because when you think about application, you just know that an application comes to life. But there's something that has been done for it to come, and there's how it's created. So for you to come up with, an application, you have to plan. You have to get the requirements, like, oh, okay, what is it that we want to create? How would it look like? What's the design? How many applications is it talking to? What's the integration? All those things are things that you not have to think about. Remember when we talked about software quality assurance and testing? Quality assurance is the process, right? So there's a process to this thing before you even go to code. So developers don't just pick up and start coding. They have thought about, this is what I want to do. And they're thinking about it based on whatever requirement has been given to them by the business or by any stakeholder that owns the application. They've said, okay, how would this application even work? Let's look at a design before you now code based on what you have designed. Then, testing is also part of it. We have to test. Then after testing, we're fit for purpose, we deploy. That's we launch to customers. Something else that we need to, or we're doing now, is after deployment, maintenance. Maintenance is now where you look at your updates and how your update happens, how your users are even, working with the application, how the application is faring out there, and the things that you want to change. Like now, this CrowdStrike issue, it's part of maintenance. So they have already deployed. It's an application that is live. People are using it. But it was maintenance that they were doing. But in your process of maintenance, where does testing come in? How does testing come in? So when you're creating a product, any application, you know that it goes through this flow. That's part of the things that I would like to highlight. But in going through the software lifecycle, it's like birthing a software. So in birthing this, how do you also test? How do you also ensure that this application is delivered bug-free? That's where you come to the software testing lifecycle. And in the software testing lifecycle, you now begin to do the same thing, but in like scrutinizing the application. So at the point of requirement analysis, the tester is trying to figure out, what is this requirement about? How is this application supposed to be delivered? Then you begin to create your test cases. What are the things that I will check in this application based on the requirements that has been given? In what environment will I check it? Because when applications are created, note that like they're not created in production environments. And when I say production environment, they're not created where users have access. They are mostly localized, or you have it in a particular server that is accessible to only the team. So when you're testing, you have to replicate what your production will be. You will need to replicate the environment where the users will be. So in testing, you're thinking about what is the setup. Part of the issues that people have is you are testing in an environment where it's not replicated, and you launch. Then you now say, but this thing, I checked it. Meanwhile, your environments, they don't mirror one another. So your experiences will be different. Those are the kind of things that causes disaster that we need to avoid. So thinking about environment setup, then your execution. Actually, so now this is part of where you actually now test the application. After testing the application, you now do lessons learned, whatever issues, reporting your issues before you close. And lessons learned are always good because it helps us avoid issues the next time. So that's really the circle of, software testing in the software development life cycle, because they will not be testing if there's no development. They will not be testing if there are no applications. So they go hand in hand, but they both have a process to it that we need to, adhere to. I'll also be talking about the types of testing. This is knowledge sharing, right? So I know there's a lot of information, but it's just information that things that normally you would not think or understand, how it works or focus on. So testing types. There's the manual testing, there's the automated testing. Manual testing is where human testers execute the cases. So whatever cases that you have created. So when you talk about the cases, what am I going to test? If I'm going to use the example of the bank app, I'm trying to verify that I I can maybe buy a time, I can transfer. When I log in, I'm able to log in quickly. Do you understand? If there are a lot of people, I remember, was it COVID, or there was one time that we had issues where people couldn't access their bank app. It was pretty recent. Why can't I remember the scenario? Where, there was so much traffic, bank apps were not opening and all that. So what was the issue? It was capacity. Was performance done? If maybe 1,000 people, oh, I think, yeah, I remember, it was during the cashless time where we changed, where there was new money, right? During the cashless policy, where everybody now started going to use their bank apps. The banks were not ready for that expansion. So they would have infrastructure, maybe infrastructure to feed, let's say, 100,000 people, and 200,000 people were hitting their system. How would the system react? Those are the kind of things that testing helps you avoid, or, so once those kind of systems are tested, they are able to now say, oh, at 100,000, we've reached our max. We need to expand if we want to get to 200,000. Do you understand? What infrastructure do we need? What's our CPU utilization? Things like that. How slow? How would the system respond? So those things are done by, either manual or automated testing. So manual testing is really where humans execute these examples that I've given, like these scenarios where humans are the ones that say, we think about it and say, this is what I want to do. Check if it's working. Can I buy data? Can I transfer? All those things are, manual testing. And for manual testing, there's a flexibility because I can think about, okay, what are the things? What are the possible scenarios? What if I have 1 million naira in my account and I try to transfer 1.5 million and it goes through? What's the impact? Do you understand? Where's that money coming from? Who is losing? Is it the bank? All those type of things are the flexibility that, manual testing will give you. User experience, like you can just open an application and it's so ugly. Like, I don't even want to use the application again. All those things are what manual testers would give feedback on. And also, manual testing helps you with engagement, early engagement. So we're not waiting for the code to be delivered before we start verifying. We're starting from the beginning. When you tell me, oh, I want to create an application, at the point of requirement analysis, when you're saying, this is what I want it to look like, as a tester, I'm thinking, it might not work that way. It might not be seamless. Maybe we should do it this other way. With that, we're already avoiding issues. So that's early testing in the early stages, or even before the developers start developing and there's already a mistake in the design, testers are able to pick it quickly. Then some of the cons is time consuming, is resource intensive, and there's limited coverage, right? Because how many things can I do? Talking about limited coverage, I'll just give a quick example. For example, maybe an e-commerce website. We already have, e-commerce website that is launched, and I want to add another module. Once I add the module, I want to be able to verify that every other thing is working properly, right? How do I want to test every single module and every single product again? That's where automation comes in. Automation really helps using tools. It would help recreate scenarios. It would help simulate scenarios, execute test cases and generate reports using tools. So it helps with speed, efficiency, repeatability. So every time that I want to impute an update or make a change, I don't have to worry about looking for maybe 100 people, 50 people to test this large application. I can simulate it, create test scripts that will simulate that and, help me execute that. Some of the cons are investment costs. It is not cheap because most of these tools are not free. Then limited applicability, in terms of, let's say, usability, how do we define even skills requirements? A lot of people are not trained in automations. We have limited automation testers. So those are some of the cons. When we look at testing types, we think about it, look at it in context of whether it's functional or not functional. So functional is most of the examples I've given in terms of, does it meet the need? I want to have an application where I don't have to walk into the bank. Everything I used to do manually, I can now do it in my device, right? Does it meet that need? Am I executing? Am I able to achieve that purpose? That's what functional testing does. But non-functional now thinks about, okay, what's the performance? If I have more people in this application, would it break? How reliable is this application? Would it be slow? Would it crash? What's the load that it can take? How is the look and feel? So non-functional testing talks about, really focuses on look and feel, usability, performance. And another thing I'd like to highlight is regression. So regression is ensuring that there's stability. We have applications that are already launched, apart from new applications. So you already have an application that is launched and you always want to update, you want to change. So how do I ensure that once I bring an update or a change, what is existing is not broken, it's still working? That's regression. Then static looks at documentation. So you don't just test applications, you test documentation as well. You test the requirements, you test the code. So these ones don't need execution. It just needs you to read, verify that, this is what it's supposed to be. This makes sense. There are no errors because it's based on this documentation. It's based on all these artifacts that the developers actually develop. And levels of testing, you can test in components. So you can test a particular component. You can test two components together. That's integration. You can test the whole system, once the system is ready. And you can test from a user's point of view. That's users acceptance testing. Am I going too fast? Am I okay? You with me? Okay, so those are the levels of testing. We can delve into this maybe in another session if Tony would have me. So I just wanted to really highlight the non-functional, functional testing where we talk about the performance. I already talked about it, how well the software functions under different workloads, reliability, the stress. Do you understand? How can you stretch the system? So at the point where we had that cashless thing, most organizations at that point, most banks, they probably did not even know the level, the capacity that their applications can take. Do you understand? What is the load? It was at that point they began to expand. They began to get new servers. They began to, they just started expanding their infrastructure to be able to take on more people. But it would have been avoided. Those are issues. Imagine the frustration of saying there was no money and you could not still use your app. Those are the disasters that we can avoid when you actually test. And testing is to make sure when you follow the QA process, is to make sure that you mitigate the risk of issues. Your users are always, have the best and quality service, usability. Then when we talk about security, identifying whether there are vulnerabilities, how susceptible is your system to hacking? How safe are you, What's the protection that you have? All these things are non-functional, but they are critical. Compatibility with an application. There are some applications that you'd see that they would work on Android and they won't work on iOS. Do you understand? Or on Apple, it has a very good experience. Meanwhile, on Windows, it's not working properly. Do you understand? So compatibility would ensure that you do that, you test that. And scalability, how are you able to scale? It gives you information on how you're able to scale when you test properly. Your reports, with those reports, you're able to make informed decision on scalability and performance. Then we go ahead and talk about the tools, because all this are not just done in we use tools as well to make sure that it's effective, it's efficient. In test management, so test management is really talking about the whole process, the process of, quality assurance and how you deliver. So test management, some of the tools that I know a few people would know, you use Jira. Jira is a paid tool, and it just helps you manage the whole delivery life cycle of how a software comes from design to delivery till gets to the users. So Jira is one of the applications that help you do that. It's paid. You have Test Trail as well. It's also paid. Then TestLink is free. So most organizations use TestLink, but because it's free, they actually, some people use, paid so that they can control what it is that they are sharing. Then for automation, to be able to have your repeated tests, to be able to do your regression, the tools that are available are tools like Selenium, which is an open source tool where you can write test scripts that simulate. So for example, I want to test an application and I need 20,000 or 200,000 users. Where do I want to see 200,000 users to log in at the same time? I can simulate it using Selenium. It's a free tool. There's also Catalan Studio. Catalan Studio has paid and free. So Catalan Studio is like a recording. You would see, the application would see how you run your test and record the process and run it again for you. Then for performance testing, we have things like Apache JMeter, which is free. Then LoadRunner is paid. And for defect tracking, because in verifying in quality assurance, you're checking to ensure you don't have defects, to checking to also find defects. How do you track it? How do you know that this defect has been fixed? And we go into the next phase, we are clean. So those things are like, you can use Bugzilla to manage it, because what if you've raised the defect, somebody has fixed it, then another developer comes and says, oh no, that thing, I didn't know that they had fixed it. I spent time and I was working on it. Time is going, you're losing resources. So you have to plan. So defect tracking applications, you have things like Bugzilla, Redmine, and all this are open source. And in choosing the kind of tool you would use, it also depends on your project. It depends on, the requirements of your project, how large, how small, depends on the scale, depends on the amount of, availability of funds, depends on costs. Those are kind of criteria that you think about when you're thinking about choosing the tools for your application. Now, let's talk about the benefits, because we've talked about the problems, we've talked about the actually executing, the process, the methodologies. But the benefit of doing this, like, there are numerous benefits. First of all, achieve consistent quality. When your product is fit for purpose, when it achieves its purpose, it's very key. It's like it's like bringing satisfaction to you. Then efficiency, cost efficiency, because the cost of non-conformance, see the data that we brought, look at that company that lost $400 million, the ninth company, lost $400 million. Also, they went under after 1 year. Globally, CrowdStrike, because of the issue that we had, they are losing up to $5 billion because of not testing an application properly or deploying wrongly. Maybe they deploy too quickly, or the process of how they deploy. When you do it right, you will save costs. You will save costs, do you understand? And you even do it early. Then process improvements. You're thinking about, okay, how will this process work? What's the learnings that you bring? You begin to impute it in, your other creations, or impute it in the process. It makes it efficient. You're managing risk, because for me, QA is risk mitigation. Let's manage risk and satisfy our customers. So you're managing risk, the impact of any loss at all. Then compliance to security. Compliance and security, you're complying. So it's not only the fact that, oh, you want to deliver an application, or, and your customers, it's also there's regulation. So there are some things that you shouldn't be. There's some applications that have regulations, the way you're supposed to be delivering and all that. So you're compliance, and then thinking about security. Also, it helps us in ensuring that our applications are secure, finding issues, bringing customer satisfaction, competitive advantage. When your application or even your service, because QA also covers services, when your service is good, you follow the due process, you follow the right process, you are ahead of competition, because you would have returning customers. People would always come back to you. So it gives you competitive advantage in any way, every time. Quality always gives you competitive advantage. You are the edge. You are always at the edge. Then continuous improvement. So these are just some of the benefits. I'm sure as I speak, some of you are thinking about other benefits, other things, other advantage of really looking at how your application is, tested, and the quality that you put into it. Then, I think looking at the poll, we had some people that are experts. I'm sure we have decision makers, people that run organizations, or maybe even senior managers, thinking about how do you make QA decisions, organizational test management. How do I bring the right people, or how do I also Do I want to bring, because some people have, let's say, small businesses, and they say, I'm just creating an app now. Why do I need to go and look for somebody? I can do it myself. Or I have a major application I want to deliver. Do I need an in-house team specialized, or do I need to outsource it to experts? Or do I need a lot of people and get crowdsourced? Those are some of the things that you need to think about as an organization when you are thinking about software quality assurance. So talking about external teams. So if you're talking about managed service, so you have an organization where you deliver applications, but you do not have an in-house test team. You can outsource your testing where the people come from outside and they're the ones, they understand your requirements. They have expertise in different areas, hire consultants, and they are able to scale up and scale down. So a lot of, organizations, CIOs are thinking, I don't want to spend so much money. If I get an in-house team of, let's say, 5-man team, I'm paying them consistently, but I have projects only a few times in a year. How would it work? So getting an external team would help you manage. So you keep them based on contracts. Okay, I need you for 3 months, I need you for 1 month. So it just, it's cost effective sometimes, scalability, you're able to increase and decrease if you have more work and you also have expertise, because most times when you get external people, they are experts in that field, experts in that area. But sometimes you want to have in-house internal team. You want to build your team. Do you understand? Have your people have areas of specialization. That's also good. You can control the information. You can control, you want to have oversight. Those are some of the things you need to think about, like in my organization, what am I prioritizing before I create or bring in, a quality assurance team? How would it work? Or you want to go crowdsource. Now you see people, a lot of testers work remotely. Like I can be here now and I'm working for a company in Canada, in the US, in Ireland. Do you understand? You are freelancing because they just need people that have the skill sets and just execute, provide reports for me, follow the process. Do you understand? There's a quick turnaround time. So where in your organization are you and how would it fit? Those are the kind of things, these are considerations you need to make when you're thinking about bringing QA in as an organization level. And even as a tester, thinking about it, where do I fit in? Do I want to, work with an organization, an internal team? And sometimes I'm thinking, oh, okay, I'm specializing in this area, so I'm an expert in banking solutions, or I'm working with an organization that, is a consultant and I can work on banking solutions. I can work in telecom space, I can work in healthcare, what kind of skills do you want? What kind of experience you want to garner? So whether you're the manager making a decision, your CEO making a decision, or you're somebody that wants to go into this, think about, how you would fit, in what area you fit. Or someone that wants to jackpot and you want to do freelancing, we have space for you. So I'll also just be talking about some of the trends, because testing.
Almost out of time.
What you say?
Oh,
okay.
Well, please go ahead.
Oh, okay. I'll just
I'm hopeful
quickly.
that
I
we'll be
think we
able
have
to
2 more
touch.
slides to go. Yeah.
Okay, great.
Yeah, so SQA trends, some of the trends that have happened over time. So we're talking about AI and machine learning, where you have artificial intelligence being the one to simulate where a possible defect would occur. This would bring efficiency. So those things are already happening. That's where we're generally moving to. Then shift left testing, where we're testing from the beginning, or automation. I talked about continuous integration, continuous development. That's the DevOps and all. Then security testing. These are some of the trends that are going on in testing. Then focusing on opportunities, like the research that's been done is that, software quality assurance market now is valued at 17.7 billion as at 2022, and it's growing by 14%. So imagine where we will be at 2028. And most organizations, now even this crowdsourcing, I was looking at their report and they're already increasing their budget for testing, they're increasing their processes. So 62% of IT budget now goes into quality assurance. It's so key, like there's a demand for it. And LinkedIn has already started putting it as top emerging jobs in technology. So the opportunities here are really, really great. But when you look at the path, so whether you're entry level, you'll be a QA analyst, mid-level, advanced level, there's where you can fit in. And there are also specialized roles. So talking about performance is a specialized role, automation is a specialized role, UI UX is also a specialized role. And other disciplines, this is one key thing that I always tell people when you're coming into software quality assurance. Like, it excites me. The fact that you see that software development lifecycle that we talked about, where you have your product manager, you have your solutions architect, you have project manager, you have business analysis. In that lifecycle, the tester interacts with everybody. The QA person interacts with everybody. So you begin to gain experience. So it's mostly easy to transition in once you start as a QA personnel. It's very easy to transition. And the path for you that you do not have any experience at all, you just need your soft skills. You need to be able to collaborate, attention to detail. You need to really have keen eye for details. You need to be able to communicate very well. That's all you need. I've had people, even people that I started QA with, someone was like, I had someone that was a lawyer. She did not want to do law. She just did it for her parents, and she wanted to do something else. We started together, and now she's like a top level business analyst because she has moved from QA now to business analysis. I've had someone in my team that studied botany. I've had people that studied mass comm, like different. It has so much like low entry barrier. Just have your soft skills, pay attention to details, be ready to learn, be open to foundation level training. You'll be able to break into this market. Then if you're in your mid-level career, you're already a developer, just, be able to proficient in the tools that you use, programming language, all this are, the paths that you can go. And another thing I like to always highlight is certification. It stands you out, you get, because in this area where you always have to define what you are doing, once you're certified, it gives you an edge. It's like a door opener for me, and it just says, okay, yes, this one is really in it for it. And one of the things that we all need to do, like what we're doing now, knowledge sharing areas, workshops, webinars, be involved, put yourself out there, attend conferences, join communities, do you understand, where you can get information. All these things will give you like a direct path into becoming a professional. In summary, what I'm saying is implement the methodologies. Do you understand? Ensure that you are doing comprehensive testing before any launch, before any deployment. There are diverse career paths that you can go through when you start software quality assurance. Do you understand? Continuous learning is very key. It is very key in any path. It's very key in software quality assurance, because we are in an evolving world. Things are changing every time. And effective use of tools. You can have tools, but you're not using it effectively. So you have to know when to use one particular tool, what decision to make at any point in time in terms of your tools. Those are some of the things that you need to think about when you think about quality assurance as a whole. I think that's where we will call it a day. So for me, I would say next steps will be, join a community, get professionally trained, but just ruminate on the impact of, non-conformance and what you need to do to conform and deliver quality and to have resilient systems. Yeah. Thank you. I think that's
all right.
Yeah. Over to you, Tony.
Well, has used up our time, but it has been an interesting session, right? Very interesting session. And we have very interesting questions in the chat, which really I'd love for us to take every question before we end. So guys, can we do an extra 10-15 minutes max? If that's fine, just type a Y. If not, we don't want to take so much of your time, but okay, brilliant. Okay, fantastic. Okay, I'll start from the easiest. And I think it's Comfort who is asking. She's saying, must I know how to code as a software quality assurance person? Is a yes or no?
Okay. No, you don't. I think I mentioned it, yes. So
fantastic.
Enter, you
so
don't.
Comfort.
You don't.
Comfort, we are done with your question. Let me start from the top now. Let me start from the top. And it's Let me see. Okay, is Lucas. Lucas is saying that I'm currently supervising a large-scale cloud-hosted application. I would like to clarify. No. So sorry, let me take this one first because I think there are two that ask the same question. It says, how safe is using Selenium and other open source online testing sites? How safe is it? And I'm sure Tunde is looking at this from a security standpoint and a
Standpoint.
performance standpoint. Because again, if you look at what happened at CrowdStrike, they said it was one of their testing solutions that had a bug in it. I don't know if it's
Yeah.
open source or proprietary, right? But Tunde is asking, how safe is using open source online testing sites?
Okay, to be honest, obviously proprietary will give you more security, but can you afford proprietary? That's another thing. So you're going to be measuring your risk, right? So that's where it is. But Selenium Pretty is actually like, I don't know, with trends, I've not seen like a lot of issues, like security issues, because they also embed security into it, even if it's open source, right? The security, there's some sort of security that is embedded, but normally it's always better to use applications that are not open source. But we're thinking about affordability. So where are we with that? But most organizations always go for paid. Most organizations that can afford go for paid so that you are secure, you are sure, and someone is accountable.
Yeah. Accountable. Yes, I like that statement because I need to be able to have someone to hold responsible. Imagine something breaks and I can't say what exactly has, I can't hold somebody accountable for it. It's not like it solves the problem, but there should be somebody who should take responsibility for stuff. Okay, Lucas says, hello, nice presentation. I'm currently supervising a large-scale cloud-hosted application. I would like to clarify the testing done by developers vis-a-vis the testing I will be responsible for. Okay.
So developers do unit testing. So they test their code to ensure that, the simplest components. That's why I showed that, like, this whole thing is, this class is 6 weeks class, but that's why I showed the trajectory, the flow. So from units to system. So developers do units, they test their components, they understand the code, how it's supposed to work, if there are errors in the code. But you would now be testing the system itself, the functionality and the security features. Do you understand? So as maybe a security person or even a normal functional tester, you'll be testing the application from the business user's point of view, from the business requirements point of view, like what is this supposed to deliver? A developer mindset might be clouded. Do you understand? Because in their mind, I already know what I've done, but you would be able to see loopholes. So you are trying to break the system to see how it would receive. Do you understand? How resilient the system is. So developers are responsible for their codes while you are responsible for the other function, both functional and non-functional.
All right. Ayotunde says, what are the most common challenges you face during testing and how do you overcome them? Or maybe just one or two.
Okay, sorry.
How do you
Okay, so for
them?
me is collaboration. One thing, like now, this question of developers, what's developer doing, what's tester doing? Sometimes developers will tell you, I know, like, why do I need a tester? I'll do it myself. So collaboration is very key. If you're able to collaborate, you're able to get the developer or everybody in your team, on the same page to let them know that quality is everybody's responsibility and we're achieving the same goal. That is like one of the challenges. But once that is overcome, you see that everybody is working efficiently to ensure that we deliver quality. And another thing is understanding, because applications are different, to understand the different applications. So you always need to be abreast with things. So those are some of the things that I have, seen as the issues. People don't really understand how applications work or new applications, and they're not ready to learn. So you should be willing to learn and willing to collaborate with your team. It's very, very key.
Interesting. Alex is saying, in an ideal situation, who should be responsible for the development of test cases? And who should validate the suitability of test cases to the given scenario?
Please, can you take it again? Who should be
He's
responsible
saying, he's
for
saying in an
trying to look for
ideal
it?
situation,
Yeah.
who should be responsible for the development of test cases? And I think he's
Okay.
speaking to functional testing now.
Okay.
And who should validate the suitability of test cases? Because again, and it's an interesting question because it's one thing
Yeah.
to build test cases, right? I've been involved in
Mm-hmm.
a number of UAT cases where I just know that what is being done here is absolute rubbish, right? So
Mm-hmm.
who is responsible for developing the test cases? And then um, how do you validate that the adequacy of the test cases?
Okay, so testers in an ideal situation, thank God you said ideal, because most times in the environments that we have, it's not ideal. Sometimes product managers develop test cases, but the quality assurance person should be the one because you understand the methodologies, you understand the process, so you know where to look at. That is the ideal. Then who should validate? Most times it's like not just a one-man job. So you have somebody else. So it's like what I call it is like second eye view. So you probably have maybe a more senior person verify again, or even the business analyst. That's why collaboration is key. Sometimes you even run it by the developers. So there's no one size fits all. You look at your team and see the people that have more experience and say, oh, I've come up with this thing, but I want you to look at it again to make sure that we're not missing anything. Remember, we have one common goal: quality, resilient systems.
Okay, okay. It says the next question is, how will you assess code review as a function of quality assurance in the absence of automation?
Okay, so code review.
Go ahead.
I think that it's very critical. It's very critical. And sometimes you don't need like automation tools to do code review. If you just understand how code works, you're able to see where there's a syntax error or something, you're able to identify it. So that's why most times what developers do, or in ideal environment, is I develop this application, then another developer reviews my code because he understands what is supposed to be there. Do you understand?
Correct.
So yeah,
Correct.
that's really
And then
what
the
we should be
third
doing.
question, Alex, under testing types and levels, is it expected that all test types be carried out by the QA team, or it is dependent on the type of solution being developed?
So
I
it's
think you've answered
dependent.
this question.
Yes, I've answered. Dependent on the type of solution, and there are different levels. Unit testing, definitely always developers, because that's code review stage.
Hmm, hmm. And Israel, okay, says, quite an insightful presentation. Thanks. I noticed that you talked about rollout/deployment, but did not talk about rollback as a crucial part of quality assurance or damage control. What are your thoughts? I asked because every deployment or installation changes registry setup and configurations, and they form part of quality assurance. Interesting, because again,
Okay.
these are some of the
Yeah.
things that happened with CrowdStrike. Unfortunately, yeah. Go ahead, please.
Yeah, so you know that we're talking about software quality assurance, and I mentioned that it is a process. So deployment, as part of deployment, what is the process within deployment? Do you understand? So deploying is not just deploying. What's the process of deploying? So you are going to look at what's the time that you're going to run this change. What is your rollback plan? Those are part of deployment. Rollback plan is always like it's embedded in deployment. So I just didn't emphasize it, but deployment is like a module on its own. So how are you rolling back? How are you even launching? Do you understand? So those are the things that are part of deployment. So you're right, it's embedded in deployment. Rollback is always key because for CloudStrike, I think they had about 15 minutes. And that's one of the things that also helped them. They were able to roll back quickly. They rolled back quickly within about 15 minutes. They also rolled back, but the impact had already gone high. So that's all, yes, also part of quality assurance, deployment. Yeah.
Well, we've not had this number of questions in any of our sessions since we started, right? And it speaks to the quality of delivery and the depth of your knowledge in this space. We're very grateful for having you join us.
Thank you.
We'll just give an opportunity for, we have 5 minutes. So in 1 minute, can we have maybe somebody from the audience who wants to ask a question? Just take only one person.
Please still want to ask a question.
One person. Again, if you look at the chat, I'm going to try to drop this. Or can you paste this link in the chat?
The chat.
Yes.
Okay.
So, like I said earlier at the beginning, OI is committed to empowering the next generation of software testers, right? And so there's a community, if you'd like to join that, right, on WhatsApp, where she offers mentorship and other capacity building programs for people who are interested in this domain of software quality assurance. I'm interested, right? And I'm hoping that we will too. Okay, I don't see any hands raised, so it's a good place to close. So guys, for those of us just joining us, this is the Tech Assurance and Advisory community. That's who we are. And just like we are committed to building capacity and raising thought leaders in the tech space, right? We have friends come in, share knowledge from time to time, and we're doing this for over 2 years now. It's also a talent hub, right? It's also a talent hub for people looking to recruit. And for those of us who are there, you can testify to that fact. And so if you're also looking to join the Tech Assurance and Advisory community, well, please could you help me paste the second WhatsApp link as well? You can do that. Our page on LinkedIn is displayed. All our sessions are uploaded on YouTube. And so you can also check out our YouTube channel for our past sessions, right? Okay. Well, please also help me paste the LinkedIn and YouTube for those who may not see it. And we will take, Mohammed has his hands raised. Mohammed, go ahead, unmute yourself in a few
Hi,
seconds.
Tony.
Yes,
Yeah,
sir.
thank you. Thank you so much for the interesting topic today. And I would like to thank the instructor and the consultant for this very informative topic. I have a quick question. She mentioned that unit testing would be held by the developers, while the remaining testing types would be held by the quality assurance team. But I would like whether such scenario would be applicable in the DevSecOps practice, or what would be the case there. I mean, the distribution of the testing type in a DevSecOps practice. Thank you so much.
All right. All right.
Okay, thank you, Mohammed. So yes, typically in DevOps, different people have different skill sets. So, it's a development and operations team. So you already have development skill sets as the operations team. So in DevOps, it doesn't really apply. In DevOps, whoever has a skill set, but you are independent. It's not the person that created it that will test it. It will be somebody probably in the operations team or another person part of the project team that will test it. So there's really that collaboration and integration, but you have the skill sets to be able to test the code. That's really why it's continuous integration, continuous development. So difference, and part of the things that I mentioned during this session is, you use the methodology based on your environment and based on your project size. So in, maybe subsequent learnings, we can now break down those areas. So it's not one size fits all, just to clarify.
Okay. We have to go, guys. The presentation will be shared on the LinkedIn page and the WhatsApp group. The recordings will be available 1 week from now or less, right? So until next month, thank you very much for joining. Thank you for your time. Any other questions we have, Uwa is also part of the Tech Assurance group. We can drop her a message there and she'll be quick to respond. Thank you.
And you can join the SQA group so that we have these discussions, because really that's part of the things that we want to achieve. Just bring, awareness standards to the system.
Correct. Okay.
Thank you.
So, let's all have a great weekend. Thank you. Bye.
Thank you, everyone. Bye.
Bye.